Assalamualaikum warahmatullahi wabarakatuh. Today I will present my answer about the ocean ion fertilization. What is ion fertilization? Ion fertilization is the stimulation of phytoplankton growth in the upper layers of the sea by the addition of iron. The Martin hypothesis suggests that ocean ion fertilization could be an effective method for stimulating oceanic carbon sequestration through the biological pump in iron-limited, high-nutrient low-chlorophyll H&LC regions. How did they know about the atmospheric gas composition in ancient times? Based on the finding, they found that trapped air bubbles in Arctic-Antarctic ice cores that have been revealed the atmospheric carbon dioxide (CO2) during the last glacial maximum LGM about 2,000 years ago was much lower than during the pre-industrial times. The dust inputs at the time are generally regarded as a major natural ion source for ocean fertilization, and Martin hypothesized that during the LGM, increases dust inputs will relieve ion limitation and substantially enhance the biological plant. Martin's finding. Late 1980, John Martin studying the role of iron as a macronutrient in phytoplankton. In that area, uh, Martin found the phytoplankton growth is low because of the lack of iron supply. All nutrients needed are there, such as nitrate, phosphate, and salicylic acid, but not iron. Martin concludes these areas of the ocean known as high nutrient low chlorophyll regions. What is the main objective of this ocean fertilization? The main objective of this ocean ion fertilization is to reduce and remove the CO2 in the Earth's atmosphere and to enhance the sequestration of CO2. This is the area of ion fertilization which is the experiment conducted. The real-world experiment has been focused on H&LC area of the ocean. H&LC area included the equatorial Pacific, Southern Ocean, and subarctic North Pacific. There are 13 experiments in total, which is 2 in equatorial Pacific, 3 in the subarctic North Pacific, 7 in the Southern Ocean, and 1 experiment was conducted in the subtropical North Atlantic, where it's known to be a low nutrient and low chlorophyll LNF regions. Why are these places interested by scientists and industry? There has been enormous interest in ocean ion fertilization. Only small amount of iron. This is because the only small amount of iron is needed to stimulate a strong phytoplankton response. With the scientists' discovery that phytoplankton growth can be stimulated by the addition of iron to H&LC waters, and some have proposed that the biological pump could be enhanced by fertilizing the ocean with iron. Importance of ocean ion fertilization. Iron-climate relationship. Human activities have caused a rapid increase in atmospheric carbon dioxide, which atmospheric carbon dioxide can be reduced by the enhancement of biological carbon dioxide uptake, including ocean fertilization. Ocean fertilization will target the drawdown of atmospheric carbon dioxide by nutrient addition, which is iron, nitrogen, or phosphorus compounds. This will stimulate phytoplankton growth, and carbon will export to the deep ocean or sediments by the ocean biological pump. The ocean biological pump is which organic matter produced by phytoplankton is quickly transported to deep waters. The effectiveness of the biological pump is controlled by the supply of macronutrients from the deep ocean into the mid layer. Iron acts as an essential micronutrient to stimulate the uptake of macronutrients for phytoplankton growth. The increase of iron in the ocean layer will cause the phytoplankton bloom, and phytoplankton will take the atmospheric carbon dioxide, and when the phytoplankton die, it will sink down into the deep ocean and the carbon will sequestrate into the sediment. This is the illustration how the iron cause a growth of phytoplankton which capture carbon dioxide and the deep plankton which sink and infiltrated the sediments and deep ocean, and some will reach depth where carbon may stay for 100 years or more. How many experiments have been performed so far to study ocean ion fertilization in the field? Okay, there are 6 natural ocean ion fertilization experiments and 13 artificial ocean ion fertilization experiments that have been performed. This is the 13 artificial ocean ion fertilization experiments. Ion Experiment 1, Ion Experiment 2, the Southern Ocean Ion Release Experiment, Asian Experiment, Southern Ocean Ion Experiment North, Southern Ocean Ion Experiment South, European Ion Fertilization Experiment, Surface Ocean Lower Atmosphere Study Solar RC Gas Exchange, Indo-German Ion Fertilization Experiment, Subarctic Pacific Ion Experiment for Dynamic Study 1, Subarctic Ecosystem Response to Ion Enrichment Study, Subarctic Pacific Ion Experiment for Dynamic Study 2, and the last one is the In situ phosphate and ion addition experiment. There are several limitations that have been classified as potential causes for the unsuccessful finding of the study. Most of the experiments face the limitation of the insufficient experiment duration, like limitation by storms, uh, happen to recent experiment, high dilution rate by small batch size. Number 4, no export floods measurements in the deep ocean, which happened to ion experiment 2. 5, single ion addition, and 6, no direct measurement of report classes with sediment traps. Are all these experiments success? No. These artificial ion fertilization field experiments have demonstrated that primary production can be significantly enhanced by the artificial addition of iron. In the Southern Ocean European ion fertilization experiment, there is no significant change in the effectiveness of artificial ocean ion fertilization because the amount of iron-induced carbon export floods below the winter mid-layer depth has been detected. Potential future for ocean ion fertilization. How to improve the experiment in the future, and what should be considered to ensure the future experiment achieve its main goal. To improve the experiment in the future, scientific artificial ocean ion fertilization research has focused on improving the understanding of the effectiveness, capacity, and risk of ocean ion fertilization as an atmospheric carbon dioxide removal strategy both in the future and the past. Accordingly, physical, biogeochemical, ecological models and natural ocean ion fertilization experiments, which is a long-term one, have been conducted in an effort to overcome some of the limitations of short-term of artificial ocean ion fertilization experiments. What should be considered to ensure the future experiment achieves its main goal? Experiments conducted must be in the center of an eddy structure when resin pressure, flow, and silicate levels are high. Shipboard observations extending over a minimum of 14 days with multiple ion injections. Freeze the ion fertilized batch using both physical and biogeochemical traces, and monitoring of side effects of marine ecosystems, inclusion of climate-relevant gases, decline in oxygen inventory, and development of toxic algae blooms, with optical sensor equipped with autonomous mode on vehicles. That's all about the presentation of ocean ion fertilization. Thank you.